Now, there are some challenges that test your patience and determination like no other. One such challenge that was knocked out of the park was by Jeremy Harper of Birmingham, Alabama, where he was able to set up a Guinness World Record by verbally counting every number from 1 to 1 million. Now, this huge task took him 89 days, where he was working for 16 hours each day. And as you can see, on average, he was counting 11,200 numbers per day. Now, since we are already on the topic of counting, let me take you back some 60,000 years to show you how counting may have started. Now, there is archaeological evidence, I've listed down the source here, that shows we may have started counting 60,000 years back. Okay, as you can see in this picture, there are lines on the bones and they are quite straight, and archaeologists are thinking that this may have been some form of counting that we started. Okay, and you also study this idea in an introduction to statistics. Yeah, the concept is called tally marks, by the way, pretty ancient. So this is how it works. Like if you want to count, like this is 1, 2, 3, 4, but the fifth one is we cross it out. So this symbol here, 4 lines with a cross, represents 5. And then you go like this: 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if you were to represent, like let's suppose the number 8, you would do it like this: 1, 2, 3, 4, 5, 6, 7, 8. But I hope you must have recognized the problem with this system. Try representing a number like, let's say, 10,000 using tally marks. Unless and until you're trying to set up your own world record by setting up the biggest number possible using tally marks. But yeah, it gets quite tedious, I'm sure of that. That's the reason why world record comes into the picture, right? So not recommended in case we want to represent large numbers. It gets quite out of control. After the, of course, ancient number system, humans were evolving, our thinking, our thought processes were evolving. So the next known is the Babylonian number system, where for the first time, we assigned symbols to represent numbers. Again, not a great system if we want to represent large numbers, but yeah, some parts of it are still being used today. Like this worked on, unlike our number system, which is decimal, like it uses 10 digits, this one used 60 symbols. So some form of it is still relevant today. Like 1 hour, as you know, has 60 minutes, right? 1 minute has 60 seconds. And if you know the circle, the complete angle is 360 degrees. So some form of it is relevant, but then again, not a recommended system to be employed if you want to represent large numbers. And then after this, we all know of it, right? The Roman numeral system, where again, we were working with a similar idea where we were assigning symbols to represent numbers, and using these symbols we were able to construct some big numbers to a certain extent. Like if you have observed the Statue of Liberty, there's a date written on the book, which is 1776. And if you want to represent that using the Roman numeral system, this is how you would do that. So hard to read, of course, difficult to scale up. And then again, as I said, not a recommended method to be used if you want to represent large numbers. But then again, thanks to the invention of zero, we have our own decimal number system that we use today, where we just use 10 digits. Please remember this. We simply use 10 digits. What are the 10 digits that we use? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. We use these 10 digits, and using these 10 digits, we can create any number possible by simply assigning a position, right? That's where place value of digits comes into the picture. Like let's suppose, take this number for instance, 753. Now you all know that this digit 3 is at the units place, so we call it at the ones place, and this digit 5 is at the tens place, and this digit 7 is at the hundreds place. And if I were to break this number down using their place values, how would I do it? Since 7 is at the hundreds place, I'll multiply 7 by the place value of it. And then 5 will be multiplied by its position and 3 will be multiplied with its position. And then eventually you'll get the same number back, 753. So assigning a digit a position, we can create a number as big as possible. Right? So this is what you got to hang on with. That's it. They are 10 digits and this is the place value of digits. Now tell me, how would you break this number up? Like 8,357. How would you break this up? Now, you know, this is 7 is at the ones place, 5 here is at the tens place, 3 here is at the hundreds place, and 8 here is the digit at the thousands place. And if you were to break it up, this is how you would break it up. So 8 gets multiplied with 1000. 3 gets multiplied with 100, and then 5 gets multiplied with 10, and your 7 gets multiplied with 1. Now sometimes we may have to apply the same idea on a number that is not known. Okay, like let's suppose I have some 2-digit number. I don't know what that is. Let the number be some AB. Now I may have to break the number down. How would I break the number down? Now this 2-digit number AB can be written as 10A plus B. Now if you can hang on to this thought, trust me, you can solve some really good problems that employ this simple concept. Come on, let's go ahead and check out a few questions. Here's the first one. Now my suggestion as usual is for you to pause the video and try to solve the question on your own. I'm sure you've done that. Now let's try to do this together. Let's read the question carefully first. Now this one says, when you reverse the digits of the number 13, the number increases by 18. Is it so? Let's check it out. So what happens when you reverse the digits of 13? What do you get? 31. Does it increase by 18? Let's see. What is 31 minus 13? Of course, you do get 18, right? So yeah, the number increases by 18. So it's asking us how many other 2-digit numbers also increase by 18 when their digits are reversed. Now, I'm not going to do a hit and trial here because how many 2-digit numbers are there? I've got 10, 11, all the way up till 99. So I'm not gonna like pick each 2-digit number, reverse it, take the difference and check which has increased by 18 or not. Like in this case, 13 does increase by 18 and become 31. I know number system, right? We know place values. Let's use that to figure out the solution to this question. So what I'm gonna do is, I'm gonna call upon algebra, okay? And I'm gonna generalize it. Since I don't know the 2 digits, I'm gonna go ahead and say that, hey, let the 2-digit number be some A, B. All right, so this is my 2-digit number. Now what happens if I reverse the digits? If I reverse the digits, it becomes BA, right? And now AB will increase by 18 to become BA, right? So let's write that down here. So AB plus 18 should give me BA. Now this AB, mind you, is a 2-digit number, and we've already seen how to break a 2-digit number down, right? By the way, I'm going to do that here. So how do I work this through? Let me just grab a different color to show you the differences. So I'm going to break the number AB here. By the way, AB is a 2-digit number. It's not A times B here. Okay, so AB, break it down. How do you break it down, guys? 10A plus B increases by 18, and then you get BA. Break down BA again. Now this becomes 10B plus A. Now let's get all the A's and B's to one side, shall we? So if I bring these guys here, what do I get? I get 9B minus 9A is equal to 18. Now if I take 9 common, throw it to the other side, I'll end up with B minus A is equal to 18 divided by 9 is how much? 2. Good. So now what are B's and A's here? They are digits. How many digits are there? 10 digits are there. So now you've got to tell me digits. Something minus something is 2. So B minus A is 2. What are the possibilities? So 9 minus 7 is 2. By the way, these are the possibilities for B and A, because I should get B minus A as 2. So yeah, B can be 9 and A can be 7. Any other possibilities? B can be 8. Then A has to be how much? 6. Then B can be 7. Yes. Then A can be 5. If B is 6, then A has to be 4. What are the other possibilities? if b is, let's say, 5, then a has to be 3, because 5 minus 3 gives me 2. If b is 4, then a has to be 2. If b is 3, then a has to be 1. If b is 2, then a has to be 0. But am I going to take this possibility? No, because then AB will become what? AB will become 0, 2. Is 0, 2 a 2-digit number? No, it's not a 2-digit number, right? So how many such possibilities are there? These are the various combinations. And I'm not going to take 3 and 1 because that was already given to us as an example. So what are the 2-digit numbers possible? 79 is 1. 68 is 1. I'm taking AB to be the possibility here. 57 is 1. And then you've got 46. Then you've got 35. Then you've got 24. And then of course you have 13 and 2. But 0, 2 is not a 2-digit number, right? So these are the 6 possible numbers which, when you reverse the digits, the number increases by 13. This, boys and girls, is a structured way of thinking using a very simple idea, of course. Okay, so I hope this is understood. Come on, let's go ahead and check out one more question. Here's the second question. All right, something similar. Let's break the question down, do it step by step like we always do. So a number, this guy says, is interesting if on adding this. By the way, again, the recommendation is always there. Pause the video and do try to solve the question on your own. Okay, a number is interesting if on adding the sum of the digits of the number and the product, the result is equal to the number. Okay, let me try to understand this by taking the help of an example. And by the way, numbers between 10 and 100, both 10 and 100 are included here. So 2-digit number mostly, because 100 is the only number which is a 3-digit number here. Let me suppose, you know, the number is, let's say, what do I take? 23. Okay, let's take the example of 23. What do I got to do here? It's interesting if on adding the sum of the digits. Okay, I got to add, what is the sum of the digits? 2 plus 3. The sum of the digits is 5. And then I also have to do the product of the digits. What is going to be the product of the digits? 2 times 3. This is 6. Now I have to add the sum of the digits and I have to add the product of the digits. What am I getting when I add 5 plus 6? I am getting 11. Is this interesting? No, this is not interesting. When would this be interesting? If I got the original number back. Okay. Am I going to use hit and trial to work this question? Of course, no. Too many numbers for me to work upon, and generally not a recommended way of working this through. What do? I call upon algebra, right? So I assume, since I don't know what the digits are going to be, I assume any 2-digit number. Okay, let me erase this out for you here, since you've already understood what the task is. Don't have much space to write this through. All right, come on, why don't you go way faster? Okay, cool. So let's just say my number is some AB. Okay, this is my 2-digit number. What are we doing here, guys? We have to first take the sum of the digits. The sum of the digits is going to be what? A plus B. Okay, and then what is the product of the digits going to be? A multiplied with B. And what do I have to do? I have to add the sum of the digits. Sum of the digits is A plus B. And then I have to add the product of the digits as well. A multiplied with B, I'm going to write it like A dot B. Okay, now this should be equal to the original 2-digit number. What is the original 2-digit number here? AB. By the way, I hope you have understood the difference. This is A dot B. A dot B means A multiplied with B, whereas this is just AB, which is a 2-digit number. Okay, so don't go ahead and cancel these two off. These mean the different thing. How do we expand a 2-digit number like 23? How do we expand this? This 2 is at the tens place, so we do 2 times 10. And this digit 3 is at the ones place, so I do 3 times 1. I'm gonna apply the same treatment to this 2-digit number AB as well. And if I simplify this, what do I get? I'm adding the sum of the digits AB and the product of the digits, and then I'm opening this up. What am I getting? 10A plus B. Right? Now I'll go ahead and simplify using our rules of algebra. So what will happen? B here will get cancelled. I'll get this A to the other side as well. And what do I have? A multiplied with B is equal to 9A. Right? Now since on the left hand side it is A multiplied with B, I'll divide with A on both the sides and this gets cancelled. So I'm getting the value of B here. B is 9. Right? Now, is there any way in which I can get A? Not possible, right? Which means it can only mean one thing. A's value doesn't matter. Okay, let's try to check it out. What happens if I take A as 1? What is the number AB? AB is 1, 9. Okay, then I can take A as 2. The number is 2, 9. Then A as 3, 3, 9, 4, 9, 5, 9, 6, 9, 7, 9, 8, 9, 9, 9. I think this pattern of adding the sum of the digits, like let's use it on 39. What is the sum of the digits? 3 plus 9. And what is the product of the digits? 3 times 9. What happens when you add them? What is 3 plus 9? 3 plus 9 is how much? 12 plus 3 times 9 is 27. 12 plus 27, aren't you getting 39? And I think you'll get it on every possible number here. So these are all your interesting numbers for you. Interesting question as well, right? And how did we solve this interesting problem? Simple. Just by knowing how to break a number down by using the place value of digits. That's all, right? Simple question. So let's move on to the next one now and see how the third question is like, the last question. So again, let's read it carefully, and the usual recommendation, pause the video and do try the question on your own. This time I'm going to go back to yellow. Okay, so the digits of a 3-digit number A, so it's clearly mentioned that here A here is a 3-digit number, are written in the reverse order to form another 3-digit number B, and they've also given here that this number that you get after reversing, that is B, is bigger than A. So let me go ahead and take A as some XYZ. XYZ is what? It is not X multiplied with Y multiplied with Z. XYZ here is a 3-digit number. And how do you open a 3-digit number? This is 100x plus 10y plus z, because x here is the digit at the hundreds place, y is the digit at the tens place, and z is the digit at the ones place or the units place. Now, if I reverse the digits, what do I get? Z, y, x. And this is b, right? Again, let's open up b as well. So this would be what? 100z plus 10y plus x. And I know b is more than a, and b minus a is what I got to do now. So let's do b minus a now. B minus a will be what? B is what? Your 100z plus 10y plus x. This is your b, right? Now from this I have to subtract a, and I've opened up a here. So that is 100x plus 10y plus z. Now do your algebra and tell me what do you get here. So 100x, 100z minus z is your 99z. 10y minus 10y will get cancelled. X minus 100x is minus 99x. So if I take 99 common, I'm getting z minus x inside the bracket, and this is my b minus a, right? Great. Now the last hint that I have to work upon is that b minus a is perfectly divisible by 7. All right. Now what do you mean when you say perfectly divisible by 7? It means that this has to be a multiple of 7, right? So 99 is not divisible by 7. You check that out. When you divide 99 by 7, you will get some remainder. It's not perfectly divisible. So the only possibility that is left out now is, grabbing a different color, z minus x should result in some multiple of 7. That's the only possibility. Why? Because 99, look, when you divide this by 7, 99 divided by 7 gives you some remainder. Okay, so obviously it is z minus x divided by 7, which should not leave any remainder. If it does not leave any remainder, it has to be a multiple of 7. What are multiples of 7? 7 times 1, 7 times 2, 7 times 3, like that. Okay, so the first possibility is z minus x is 7. Then, okay, when is this possible? Digits, by the way, x, y, z here are digits, and how many digits are there? 10 digits. I told you to remember that in the first case itself. So tell me, some digit minus some digit gives you 7. What are the possibilities? Let's start with 9, shall we? So 9 minus 2 gives me 7. Then 8 minus 1 gives me 7. Yes. 7 minus 0, I can't take it. Why can't I take it? Because then x becomes 0. Then if x becomes 0, is this a 3-digit number? 0, 2, 3. 0, 2, 3 is not a 3-digit number, and it's clearly mentioned here is that a is a 3-digit number. So this possibility is ruled out. So the only two possibilities are x can be 1 and z can be 8, or x can be 2, z can be 9, right? Now you must be wondering, hey, why did you only go with 7? 14 is also another multiple of 7, right? Now tell me, z minus x is 14. Z here is what? Z or X are digits. How many digits are there? 0 to 9. Now, can you subtract any two digits and get 14? Not possible, right? So that is the only possible combination. So what are the possibilities? Find the minimum possible value of A. So A here is what? XYZ, right? So A here is XYZ. And since it is asking us minimum, we'll take this possibility. X being 1 and Z being 8. Now what is the minimum possible value that Y can take? Minimum possible digit. Y can take 0, right? That's it. There you go. That's your answer. So I hope this was understood, right? I may have gone a little bit faster because I know once you've understood that there are only 10 digits and you've understood the possibility as to what a multiple of 7 means, you can try the question on your own, right? So that's my suggestion to you, okay? Do try to solve this question on your own, because trust me, mathematics is best learned when you try to solve problems on your own. Okay, so until next time, take care of yourself.